Infinite universe. If the universe is spatially infinite and matter is distributed roughly uniformly throughout it, then every possible arrangement of particles must occur somewhere, and that recurrence is exact. A physical copy of you exists, along with every possible variation of your life, at distances so large they cannot be observed even in principle. This requires no new physics. It follows directly from an infinite universe and the finite number of ways particles can be arranged within any given region. The observable universe, the sphere of space whose light has had time to reach us, is a small window into something that may have no edge. Many worlds. In 1957, Hugh Everett proposed that the wave function never collapses. Every quantum event with more than one possible outcome produces every outcome, but in separate branches of reality. When a radioactive atom decays or does not, the universe splits. Both results occur. You exist in one branch. Another version of you exists in another. The branches do not communicate. They accumulate without limit, one branching event for every quantum interaction in every particle everywhere. Inflationary Multiverse. The leading model of the early universe holds that space expanded exponentially in the first fraction of a second after the Big Bang. In most versions of this theory, the expansion never fully stops. It continues in regions that have not yet decayed into normal matter and energy. Our universe formed when one region stopped expanding and cooled. Other regions do the same, each producing its own bubble universe with its own Big Bang and its own physical constants. The inflating space between bubbles expands faster than light, keeping every bubble permanently isolated from every other. Brane Multiverse. String theory requires more spatial dimensions than the three we experience. In M-theory, the most developed version, there are 10 spatial dimensions. The three large dimensions we inhabit are confined to a surface called a brane. Other branes may exist in the higher dimensional space surrounding ours, called the bulk, separated by distances we cannot measure directly. Each brane is a universe. If two branes collide, the energy of the impact can ignite a Big Bang. The ekpyrotic model proposes that our own Big Bang was exactly this: a collision between two branes that had drifted apart and been pulled back together. String landscape. String theory does not predict a unique universe. Its equations allow approximately 10 to the power of 500 distinct solutions, each with different physical constants. The mass of the electron, the strength of gravity, the value of the cosmological constant, all could take different values in different solutions. The full set of these configurations is called the landscape. We occupy one of them. The anthropic argument holds that we necessarily find ourselves in a region where the constants permit complex chemistry and life, because no other configuration could produce anyone to ask the question. Cyclic Multiverse. Some models propose that the Big Bang was not a beginning, but a transition. In the ekpyrotic and cyclic models, the universe expands, cools, and eventually the conditions reset, either through a brane collision or a cosmological contraction, producing a new universe with new initial conditions. In the conformal cyclic cosmology proposed by Roger Penrose, each aeon ends as all matter decays and black holes evaporate, leaving a smooth, cold, expanding space. That geometry is mathematically identical to a new Big Bang. One universe ends and another begins from the same geometric point. Simulation hypothesis. The philosopher Nick Bostrom argued in 2003 that at least one of three things must be true. Civilizations at our stage almost always go extinct before developing the capability to simulate realistic universes. Advanced civilizations that do develop that capability choose not to run such simulations. Or we are almost certainly living inside one. If even a small fraction of advanced civilizations run many simulated universes, simulated realities outnumber physical ones by an enormous margin. The probability that any given conscious observer is in the base reality becomes vanishingly small. This is not a physics theory. It is a probabilistic argument about the distribution of minds across possible realities. Mathematical universe. The physicist Max Tegmark proposed that every mathematical structure that is logically self-consistent exists as a physical reality. Our universe is one such structure. There is no distinction between a mathematical description of a universe and the universe itself. All of physical existence is simply the collection of all consistent mathematical objects. This is called the mathematical universe hypothesis. It requires no inflation, no extra dimensions, no physical mechanism of any kind. It requires only that existence and mathematical existence are the same thing. It is the most expansive multiverse proposal and the least testable. Thanks for watching. Out of every multiverse theory we've explored, which one do you believe best explains reality? Let me know in the comments. Also, if you enjoyed this video, then be sure to like and subscribe.